Alright, today we're going to learn on a new method of multiplying polynomials. So we've been doing it for a while, and here's our example of a simple one. And let's say it's going to be x plus 1 squared. Okay, x plus 1 squared. We have a 1, x and a 1 here. If we multiplied it out, x plus 1 times x plus 1, okay, it's going to be x times x is x squared, x times 1 is x, 1 times x is x, and then 1 times 1 is 1. Oh, like terms, like I didn't expect that. X squared plus 2x plus 1. Great. Good job, Ms. Crow. But then, what if I do x plus 1 cubed? And you're like, oh man, that's even more work. But lucky for us, I'm going to steal this one. Because this is x plus 1 squared times x plus 1. And we already did x plus 1 squared. That's x squared plus 2x plus 1 times x plus 1. And then we're going to go through our routine again. That's going to be x cubed plus, I'll write it out, 2x squared plus x. And then on the second line, it'll be x squared plus 2x plus 1. Hey, we have some nice like terms. X cubed plus 3x squared plus 3x, 3x, yep, plus 1. Okay? All right, and then what if I said x to the fourth now? Oh my god, x plus 1 to the fourth. Mr. Ko, what are you doing to us? We have x plus 1 cubed. All right, x plus 1 cubed, got it, x plus 1 cubed, times x plus 1 again. I feel like I'm beating a dead horse here, but this is in the front, x cubed plus 3x squared plus 3x plus 1 times x plus 1. Okay? And then we're going to multiply all this together. X cubed, not x cubed, x to the fourth plus 3x cubed plus 3x squared plus x in the front. On the next line, we're going to multiply it by 1. X cubed plus 3x squared plus 3x plus 1. And we end up with x to the fourth plus 4x cubed plus 6x squared plus 4x plus 1. Okay. And we can go on all day long with a smile. Wink, wink. Okay, we can go on all day long with this. But turns out there is a pattern to this. There is a pattern to this. And it follows a pattern, what we call Pascal's Triangle. And Pascal's Triangle is a great way for us to start talking about this. And let's look at Pascal's Triangle. Pascal's Triangle is formed by starting off with the 3 ones. Triangle of ones. 1, 1, 1. Okay? Pascal's Triangle is always formed and it will always look the same way. The next one, we always start off with 1. And then you add the last 2 values right on top of it. What's 1 plus 1? 2. And we end up with a 1. That's how we always start out. We start off with a 1 and we end with a 1. And the way we end up with the middle value is we add the 2 values on top of that. Okay? Let's keep on going. We start off with a 1. Take a look. I don't write it underneath it. I write it next to it. Because we're trying to form a triangle here, right? We're trying to form the Illuminati symbol, right? I see you. We're trying to form that triangle. Okay. So what are the 2 numbers before it? 1 and 2 add up to become 3. 2 and 1 add up to become 3. And the last one is just 1. All right. I want you guys to come up with that next row of numbers. Let's see if you guys can do it yourself. Okay. What's the first number we write? We always start off and end up with a 1. That's how the problem works. 1. Now, what's the next number? Take a look. I drew little arrows here for 1 and 3, right? What's 1 plus 3? That adds up to become a 4. What's 3 plus 3? That becomes a 6. And 3 and 1 add up to become a 4. And we're left with a 1 at the end. Okay, the Illuminati is watching, okay? So, here is the legit crazy part now. When it comes to the multiplying binomials together, they actually form the Pascal's triangle. What I mean is, I want you to look at all the answers that we just came up with and look at the front coefficients of those numbers. Let's go back and take a look here. We start off with, if I write x plus 1 on top, if I write just x plus 1 to the 1 power, this is just 1x plus 1. This is 1 and 1, okay? Which is our first term, or the second term actually, in our Illuminati triangle. I mean our Pascal's triangle. Our next answer is, take a look here. It is 1, 1, 2, 1. You guys have your Pascal's triangle in front of you. You don't have to keep going up and down, but take a look. The next line is 1, 2, 1. Does that look familiar? Oh. Our next one, our cubed. 1, 3, 3, 1. 1, 3, 3, 1. Does that look a little suspect to you guys? Let's go on the next fourth one. We're on our fourth one now. C to the fourth power. We're on our fourth level. We have 1, 4, 6, 4, 1. 1, 4, 6, 4, 1. Anyone freaked out yet? Let's see if we can guess what our fifth one would be. Okay. X plus 1 to the fifth power. X plus 1 to the fifth power. Okay. Let's fill out our Illuminati, our Pascal's triangle here. We're going to start off with a 1. I want you guys to go ahead and fill out the blanks here. What would those be? Followed up with x to the fifth, x to the fourth, x cubed, x squared, x, and a constant at the end. And go ahead and tell me what the numbers in front of each of these exponents would be. Okay, so what's the number that's going to be here, 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 and here? Okay, I got some answers. Let's check it out. If you guys can read the chat and if you guys agree with those numbers. 1 plus 4 is 5. 4 plus 6 is 10. 6 plus 4 is 10. And 1 and 4 is 5. And 1. So we have 1, 5, 10, 10, 5. Oh my gosh, it fit perfectly. It fit perfectly. Oh, be careful. Be aware, guys. Be aware. Right? So this is Pascal's triangle. And what happens is it allows us to come up with a front coefficient of our binomials, right? And there's going to be something called binomial theorem in a little bit that we're going to continue with. But Pascal's triangle is where we get these front numbers. Does this work for if I'm multiplying different binomials? If I'm saying, for instance, like x plus 1 and x plus 3. No, it doesn't work when you're multiplying different binomials by each other. But it does work when you're multiplying the same binomial by itself, repeatedly, over and over and over. Now, a couple links. See this exponent 5? That's where this 5 attaches. Exponent 4, right? See exponent 4? That's where we're on this level here, the fourth level. And that's kind of a hint. Sorry, not this one, but this one up here. That's the wrong one. Okay, that exponent 4 on top here. The exponent 4. That's how we get to which level we're on. Okay. Now, if I ask you this follow-up question, let's do it just one more time. Let's do it one more time. If I say, what is x plus 1 to the 6th power? Let's see if you guys can figure this out. X to the 6, drop 1, x to the 5, drop 1, x to the 4th, drop 1, x cubed, drop 1, x2, drop 1, x, drop 1, and we have nothing left. And I'm going to put a plus sign. This is our basic example. These are all just pluses. But the signs could change, and I'll tell you guys how the signs could change. Okay. So let's see if you guys can fill that out using this last step here. All right, that's our last step. So we have to do one more step, because if this is 6, we need to get to our next step. Okay, hopefully you guys are writing. First one starts off with a 1. 1 and 5 become 6. Oh, that's probably obvious. 5 and 10 become 15. 10 and 10 become 20. 10 and 5 become 15. And 5 and 1 become 5. Oh, and last one is just 1. Okay, so there's this balanced order here. Now, why does Pascal's triangle work? Why does Pascal's triangle work? And actually, it's part of the way we've been writing it. And let's go ahead and examine how we've been writing it to show you why Pascal's triangle works. Now again, this is our basic example to show us the structure of Pascal's triangle. And this will work with any numbers besides 1 and 1, except besides x and 1. But we'll talk about how we have to adjust it to make it work for other numbers. Now, I want you guys to take a look here, starting from this point here. Don't we add the two levels next to each other? But what's the difference between those two levels? The only difference is because one is an x and one is a 1, right? Now, if you look at how I adjusted it, I wrote them on top of each other. And instead of writing literally on top of each other, take a look here. I'm going to write this. What if I just wrote them on top of each other like this? Okay, do the like terms match up? They don't, do they? But the second one, last one of, made a mistake over here. Yeah, this is a 6, I'm sorry. I misadded, 6. Instead of having them on top of each other, don't I shift it over? Don't I kick it over by a space? So what happens is I augment it over by one step, and that's important because all like terms now are always one step over from each other. What I mean is, take a look at what we wrote here. They're connected by one step over, right? Let me write that again. X cubed plus 2x squared plus x, and we have x squared plus 2x plus 1. They are one step over connected, right? And don't we add them together? Now, I want you guys to realize these numbers are numbers that we wrote already. That's in our triangle. We're adding the first number to the second row column. We're adding the first number to that second row column. And that's how we end up with those 3's. Let's take a look at it again. I'm adding the first number to that second row column. That's where the 2 and 1 comes in. 2 and 1 become 3. We're adding the first number to the second number. 1 plus 2 is 3. Take a look at my Pascal's triangle. 1 and 2 make 3, and 2 and 1 make 3. We're adding the shifted values that are right next to each other on top of each other. Let's take a look at this one over here. Instead of writing them on top of each other, right, we shifted them. So I'm adding the previous step 2. Look, let's call this step 1, 2, 3, 4. 1, 2, 3, 4. I'm adding 2 with 1. Okay? I'm adding 2 with 1. That gives me the 4. I'm adding 3 with 2. I'm adding the third term with the second term, which gives me 6. I'm adding the fourth term with the third term. The fourth term with the third term, which gives me the 4. And then we have the single ones at the end. Pascal's triangle. And that's what I want you guys to realize. Pascal's triangle is someone realized that you're always adding the previous term next to each other. So why not just set that up without writing any of the x's? So if you look at these, Pascal's triangle is just really adding the terms that are alike, but they're always going to be right next to each other anyways. This 3 and 1, that's our third term, our second term, and our first term. Our second term and our first term. Our third term and our second term, third term and second term. That's how we got 6. Our fourth term and our third term, fourth term and third term. That's how we end up with 4. And our single terms at the end. It looks like a crazy mess, doesn't it? But that's the pattern of Pascal's triangle. That's where they came up with it. Now, what if these numbers, okay, what if these numbers were not easy numbers? What if these numbers were not what we just called x plus 1? That's what if we say it was x plus 3 squared? Let's look at something kind of easy. Okay, let's do cube. Let's do cube. Can we still use Pascal's triangle to do this one? And the answer is absolutely yes. Now I'm going to tell you guys some a and b values. Use a and b instead. This a is x in the front, and b is positive 3 in the back. So I'm going to take the sign and I'm going to take it with you. So let's look at Pascal's triangle at level 3. 1, 1, 1, 1, 2, 1. That's not level 3 yet. 1, 3, 3, 1. That's 1 plus 2, 2 plus 1. That's how we end up with the 3. Now, this is how we're going to set up Pascal's triangle. Sorry, I changed that to a 6. Alex, thank you. Okay, so we know for sure the front numbers are going to be 1 plus 3 plus 3 plus 1. Okay, that's how it's going to be set up. But what's the exponents next to it? Because normally we write like x cubed or something, don't we? Now I'm going to tell you guys the pattern, and this is important of how we set up this pattern. I'm going to give myself a little more space. It doesn't look obvious when we first did this, but we actually are using both front terms and back terms repeatedly. And now I want you guys to follow me here and just copy and just write this. Just write double parentheses for everyone. Please write double parentheses for everyone real quick right here. So you guys don't have to overthink it. Please write double parentheses for everyone. So every term 1, 3, 5, 1, they both have a double parentheses next to it. And what do you think I'm going to plug in for this double parentheses? I'm going to plug in our a and b value. Everyone gets an x and a 3, an x and a 3, an x and a 3, an x and a 3. Everyone gets an x and a 3. So this is the part that's actually kind of tricky for kids. If anything's tricky, it's the part of exponents. Now, we're going to give our, so remember how this is our front and back? So this is what I'm going to do next. I'm going to assign the exponents to each of these. Each of these are going to get exponent on top. And here's how the exponents work. We start off with the highest exponent possible. That's a 3. If you get 3, you get 0. Meaning the exponents have to add up to our exponent up here. Okay? What's our next step? Don't exponents always go down? 5, 4, 3, 2, 1. Aren't we always dropping by 1? And that's exactly what we're doing. We're going to drop by 1. Instead of writing 3 here, we're going to write 2 here. And 2 plus 1 give us that total value of 3. Remember, we have to have 3 for every exponent. Why? Because that's our 3 here. That's why I write 2. The b value has to be 1. Next step, if we went from 3 to 2, my next step is going to be a 1. If this guy's 1, the next exponent next to it has to be a 2. Followed by 0 and 3. As one rises, the other shall fall. And I'm going to show you guys this illustrated in my little Desmos app here. So as we start off, let's use our example here. We start exponent is 3. Okay, 3. And you'll see as we move over, let me zoom in some more. Okay, so first off, we're up. We'll say 1. If you look here, 1 is my A, and over here, come on, we're having over here. This graph here is my B, right? So let me show you. There's A and B graphs here, okay? They're going to go up and down. It's like a sound system. Pop, 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 pop. Okay, sorry. Dang it, this is being recorded. Okay, so we start off with A really high at 3, okay? And then if I drop 1, the B's go up by 1. If I drop 1, A is now 1, B is 2, and if A is 0, 3 claims it all. They always have to add up to our exponent. And in this case, our exponent is going to be 3 here in blue, in B. So as one rises, the other one must fall. Sounds like twins in Mortal Kombat. Okay, so now this next step is us actually multiplying everything out. I have a 1. Don't need to write the 1, but we do need to write the x cubed. Now what is 3 to the 0 power? That is 1, okay? Anything to the 0 power is 1, so I'm not going to write it. Next step. 3 times x squared times 3, okay? 3 times 3 is 9. Next step, plus 3, I'm just writing this over again, times x times 9. This is 27x. And at the end, 3 times 3 times 3 is just 27. Okay, and just to prove that to you, I'll do this really quick on the side. You don't need to copy this. X squared plus 6x plus 9 times x plus 3 is x cubed plus 6x squared plus 9x. Take a look, that's Pascal's triangle going on here. And 3x squared plus 3x, sorry, that's 3x, 18x plus 27. We add up to x cubed plus 9x squared plus 27, x plus 27. Same answer here. It might seem like it might be more work, but meh, depends how fast you can get it done. Okay, we're going to do the same problem now, except what if it was negative? What if this was x minus 3? Okay, what happens if this was x minus 3 squared, cubed? Now, here is the setup again. We copy Pascal's triangle. Pascal's triangle is 1, 1, 1, 1, 2, 1, 1, 3, 3, 1. So we know the front coefficient is going to be 1, parentheses, parentheses, plus 3, parentheses, parentheses, plus 3, parentheses, parentheses, plus 1, parentheses, parentheses. Okay? Now, this time the numbers I'm going to write in are my a and b value. A is going to be x, and b is going to be negative 3. We're going to use these numbers here. So we're at x, negative 3, x, negative 3, x, negative 3, x, negative 3. The exponents. We're going to start with our highest exponents first. That's a 3. If you're 3, your buddy here is 0. If we drop 1, if you're 2, your buddy here is now 1 because you have to add up to 3. We drop 1. That becomes a 1 on my next step, and 2 rising up. Like a phoenix from the ashes. And next step is 0 and 3. Okay, so I'm gonna skip one of these steps. I'm gonna skip this middle step here. I'm just gonna go ahead and go to the answer. We have x cubed, because that's just a 1. Plus, careful here, what is negative 3? That's a 1, negative 3, right? What's negative 3 times 3? That's actually a negative 9. Negative 9x squared, right? Because we have an x squared here. Let's look at our next step. We have a x, but we have 3 squared. What's 3 squared? Negative 3 squared is 9. 9 times 3 is 27, plus 27, positive x. Our last step here is there are no more x's, as x to the 0 power is 1. 3 times 3 times 3 is 27, but negative 27. Let me prove that to you again. X squared minus 6x plus 9, that's x minus 3 squared, okay, times x minus 3. Just to prove this to you, x cubed minus 6x squared plus 9x, then negative 3, negative 8, positive 8, oh gosh, positive 18x. No, oh my gosh, what am I doing? I wasn't even thinking. I'm just writing random stuff. Negative 3x squared plus 18x minus 27. And if you look here, this does agree with our answer. Okay. Now again, you might be saying, Mr. Ko, I don't want to memorize all this stuff for just cubes. And the point is, sure, you don't want to do it for cubes, but what if I told you to the 4th or to the 5th power? And that's the thing on the SATs. Oftentimes SATs will ask you a question about this binomial theorem. And they're going to ask you to come up with the 3rd term, the 5th term, the 6th term. Okay, so let's go ahead and run with this idea. All right, so let's do one more here. I'm going to make it kind of interesting. We'll say 3x plus 2 to the 4th power. 3x plus 2 to the 4th power now. So using Pascal's triangle, 1, 1, 1, 1, 2, 1, 1, 3, 3, 1, or 1, 4, 6, 4, 1. Right? You do that 5, 6 times, you got most of this memorized. Okay? And if you forget, you can come up with it. So we know our numbers are going to be, sorry, I'm running out of space here, 1, parentheses, parentheses, plus 4, parentheses, parentheses. Oh my, I'm running out of space. This is a bit long one. 1, parentheses, parentheses. I should make the parentheses smaller. 4, parentheses, parentheses, plus 6, parentheses, parentheses, plus 4, parentheses, parentheses, plus 1, parentheses, parentheses. Okay. Do you really have to write the ones at the end? No, because you know they're ones. You'll start getting that. Then we're going to plug in our a and our b value. That's 3x to the front and 2, 3x, 2, 3x, 2, 3x, 2, 3x, and 2. All right? Now, what are the exponents? The exponents are the hardest part about this problem. We start with the highest exponent here of 4. So the first one gets the 4, right? Remember, always the front exponent gets the highest number. And if you're 4, the second buddy is 0. Your Robin is 0. Next step is a 3 and 1. Are you guys okay with the 3 and 1? Remember, we're always balancing out to get to my exponent of 4. Follow up by 2 and 2, right? We're balancing out now. Then we're at 1 and 3 and 0 and 4. Now, if you do this enough time, you can probably figure out what values you don't have to write, because anything to the 0 power, that's going to be a 1. That's going to be a 1. Okay. All right. Let's continue. So what is 3 times 3 times 3 times 3? 3 times 3 is 9. 9 times 9 is 81. So we have 81 x to the 4th. Okay. This is going to be a plus. 3 times 3 times 3 is 27. 27 times 2 times 4. That's going to be a huge number. I don't want to mess that up. 27 times 2 times 4. I don't know what that is. I'll use a calculator. 27 times 2 times 4 is 216. X cubed. Okay, see how that's x cubed? Because x times x times x. Next step is this is going to be a 9 times 4 times 6. You guys okay with how I got the 9? 3 squared and 2 squared. 9 times 4 times 6 is again 216. Oh my gosh, really? X squared. Then we have 4 times 3 times 8. Careful, that's 8 because 2 cubed is 8. So 12 times 8 is 96. And then we have 1x there. And last one is 2 times to the 4th power is 16. You could have told me, Mr. Ko, why don't we just multiply this by hand? It's because you would take forever with some of these large numbers when you're trying to combine it. And this is still faster than you multiplying it by hand. Okay, you don't understand how I'm multiplying them together. Let's go ahead and take a look at again how I came up with these numbers, since this is already written. So let me erase some of these here so it's less confusing a little bit. Okay, let me just go over it one more time, how I came up with these numbers. So this here is 3 cubed, right? 3x times 3x times 3x. 3 times 3 times 3 is 27. Don't forget, we're still multiplying a 2 and a 4 also. All these numbers together. So 4 times 27 times 2 is a 216. Let's look at our next step. This is 3 squared, isn't it? So 3 times 3 is 9. 9 x squared times 4, because 2 squared is 4, and 6 in the front. And when you multiply those together, you end up with, again, 216 x squared. Over here, we have 3x times 8, and then times 4. These three numbers need to be multiplied together. We end up with 96. In the back, it's 3, no, that's 3, I'm sorry. It is 1 times anything to the 0 power, anything to the 0 power here is 1, and 2 times 2 times 2 is 16. So 1 times 1 times 16 is 16. Okay. Was that a little bit better? Where I get these numbers from? All right, so on your IXL homework, they're going to use example of 2 letters. So let's use x plus a. And we're going to give ourselves the example of to the 5th power, okay? So what would I write to fill this out? Well, we know our front value is x and our back value is b. So the problem is we need our Pascal triangle to figure out what numbers we need. 1, 1, 1, 1, 2, 1, 1, 3, 3, 1, 1, 4, 6, 4, 1. I'm almost there. 1, 5, 10, 10, 5, 1. Okay, it took me about 10 seconds to come up with Pascal triangle. And that's how we're going to set it up. 1, parentheses, parentheses, plus 5, parentheses, parentheses, plus 10, parentheses, parentheses, plus 10, parentheses, parentheses, plus 5, parentheses, parentheses, plus 1, parentheses, parentheses. Reason why we need all these parentheses, remember, we need to plug in our a and our b value into these, or in this case, our x and our a value. So x, a, x, a, x, a, x, a, x, a, x, a. Now for these problems, it's not going to be that hard because there is no number in front here that I need to square or cube or whatever. So we do our exponent 5, 0, 4, 1, 3, 2, 2, 3, 1, 4, 0, 5. Take a look. The order, we go high to low. As you lose money, someone else takes it. 5, 0, 4, 1, 3, 2, 2, 3, 1, 4, 0, 5. And remember, they always add up to 5, right? 3 and 2 add up to 5. 2 and 3 become 5. 1 and 4 become 5. We're always dropping the front and raising the back. So we have 1x to the 5th. We don't need to write that 1. Over here we have plus 5, x to the 4, a, plus 10, x cubed, a squared, plus 10, x squared, a cubed, plus 5, x, a to the 4th, and plus a to the 5th. And this fits our Pascal triangle. Okay. All right. That's it.